Swayam Prabha. Digital India. Educated India.
So when we see the news, we see that around 2050, the need for the solar panel will be around 22% in the world. People will shift to solar panel technology. And in our college, when we got a major project from one of our clubs. So as a part of our major project, we started this initiative. We started this project, Suryamukhi. And after going through a lot of research papers which we read, we thought that we should be working towards the problem, that is tracking of sun and the increasing efficiency of solar panels. Because due to dust accumulation and the fixed orientation of the solar panel, it is usually the efficiency of solar panel is reduced to 40 to 60% of what actually it should be producing 100%. It is used to produce 40 to 60% due to dust accumulation and their fixed orientation. Now coming to the what we are actually doing in the product. So our product name is Suryamukhi. That itself explain inspiration from sunflower, which tracks the sun throughout the day. So likewise, our model too tracks the sunflower throughout the day. What we do is that we integrated three things. First is ML model, that is machine learning model. That is our model is ML powered. Second, IoT integration means the model actual, and we have an Android app for the user. What we are doing is that first we are calculating for a particular position, like for every position there is a different angle of suns. So using solar time, we are actually calculating the solar position. Based on that solar position, we are calculating some angles, that is azimuth angle and elevation angle. So what happens that these angles changes throughout the day. So azimuth angle, what it does, when sun moves from the east to west, so azimuth angle helps us tracking the sun east to west movement throughout the day, and elevation angle helps us to track the height of the sun throughout the day, because the movement of the sun is not a straight line. It is usually like a parabolic path, and throughout the year it is an infinity loop which doesn't meet. So in order to tackle that thing, we need these two things, that is azimuth and elevation angle, which we get from there. Second thing, we find the using weather API. For this particular location, we check pressure, wind speed, what is the temperature, what about the sky condition, that is whether it is clear or cloudy. We took these factors, and then our ML model finally predicts the tilt, that what should be tilt, horizontal and vertical tilt. Based on that tilt, it sends data to the Firebase, and from Firebase, the data is sent to the fetched by the IoT model, and the angle finally moves. This is what we are doing currently. So for cleaning part, as we know that in desert area, the dust accumulation is high on the solar panels, which reduces efficiency. So what we are doing is that we dry clean. We do not use wet cleaning, we use dry cleaning. And so in the morning, what it does, that there is a paper at the top of the panel, and using that motor, it usually when the panel becomes vertical to the ground, and then it cleans panel. This is what we are doing. It cleans the panel throughout the day, and then in the morning it goes up, the mechanism goes up the system.
This is Suryamukhi, which is a solar tracking and cleaning mechanism device which is independently developed by us. This is an IoT mechanism. We have used IoT, machine learning and Android application for this development. So this is an IoT device where it will be tracking on dual axis. This is a single vertical axis, this is horizontal axis. यहाँ पे LDR सेंसर्स लगे हुए हैं. ये क्या करते हैं, लाइट को ट्रैक करते हैं. जैसे लाइट्स आती हैं तो उनको शो करते हैं. So here it's tracking the efficient position of that light, so such that 90-degree radiance can strike upon it. तो बेसिकली तब ये ट्रैक करेगा उस लाइट को, और जब ऑटोमेटिकली डिटेक्ट करके उस पर क्लीनिंग मैकेनिज्म चालू कर दे। एक क्लीनिंग मैकेनिज्म इसमें प्रेजेंट नहीं है जो कि फ्यूचर में डाला जाएगा इस पर, जब बड़ा मॉड्यूल बनेगा वो इलेक्ट्रोमैग्नेटिक डिवाइस को यूज़ करके लगाया जाएगा। Secondly, we also have an Android application. This is the Suryamukhi app which we have developed using Android and Kotlin. So here we have temperature, humidity and location data which we are fetching from machine learning models. It shows the user the longitude, latitude, temperature, humidity, the power output, power production and the efficiency generated. So money generated or the profit generated. The user can also independently put the module in cleaning or automatic mode using this interface from here. Next, we also have a machine learning model where it shows the user, it generates the output and efficient position for the module. तो बेसिकली करता क्या है कि मशीन लर्निंग मॉडल यहाँ से डेटा लेता है, फायरबेस पे जाता है, फायरबेस से वो एमएल मॉडल में डालता है, एल्गोरिदम्स में कैलकुलेशंस होती है, वो यहाँ पे भेजता है रियल टाइम में, और रियल टाइम में मॉड्यूल मूव करती है और ऐप पे हमें शो होती है। तो पूरी मॉड्यूल में हमारा मेन यूएसपी ये है कि हम क्लीनिंग ऐड कर रहे हैं विद द डुअल एक्सेस मोशन विच कैन बी improve the efficiency of the module by 25 to 30%.
So first thing which we are focusing is that people are producing curved solar panels or see-through solar panels. So, but what about the solar panels which are existing right now? We cannot throw them because there are too many in numbers. What we are doing is that we are working for the existing frameworks, like what we can do so that existing frameworks move. We are not producing new solar panels. We are not working towards new solar panels. We are working towards the which are available. We are working that we should implement a framework which can make these solar panels move, so that it minimizes the cost also, because taking a fully new solar panel which are curved and you have previously one solar panel existing, you will not go for it. You will not buy a new solar panel. So we'll be working first thing towards that. And second thing, we are using an MPPT module, that is maximum power point tracking. What it does, that it tracks the maximum, it harnesses the maximum energy from the whole model. It tries to enhance, because after once sunlight hits the panel, usually its efficiency increases too much, but then after it start decreasing. So what it does, that in all the weather condition, whatever is the condition, it tries to make it like constant. It harnesses the constant energy and the maximum energy. That is what we are using. And what we are different in a way in our business model too. As we know, the cost of implementing this is a little bit high. Means if you are talking about industry, so it will be 2.5 years to get your ROI. So what we have done, that we are providing dual access for industrialist. Like if you are implementing in on an industrial or large scale model, so we'll be providing you dual access movement. But if you are a small farmer, or if you are trying to implement it on your home household, so we are providing you single axis. What is the difference between these two? So for dual axis, the efficiency would be around 45%, and for single axis, the efficiency would be around 25 to 30%. But the main thing is that the cost will reduce. For small farmers, for small people, the cost will reduce. So we have finally implemented the tracking part. We have to now implement, and we have to implement it on a large scale. Means we'll be testing it for maybe a month or two, so that we have a proper data. As of now, the method we are using is new. So we do not have particular data of output. So the second phase will be of implementing. Right? And the third phase will be implementing it on a larger scale, maybe on a building. So first thing, it will be impacting those, like we know about green buildings. So in green buildings, it will basically, it will not help to implement a fixed solar panel. So this design will help help them in harnessing maximum energy in very less space. Means if they have to say they have to install 200 panels, maybe they can install 100 panels, and they will harness same amount of energy in that panels. So this will help them to the green buildings, the buildings which are like Saudi Arabia, if you talk about. So there is a space, they have less space, and so they need this part. So actually what happens, that I shared my business model. So it was based for industrialists. it will have a great it will have a ROI of, they will get their ROI in 2.5 years, and it will be like they will be harnessing 45% more energy from what they are harnessing from the same space and from the existing their framework. They do not have to buy new framework for that. We'll be just installing some motors and some sensors whose cost will be too less around the market in which around the models which are present in the market. They are changing whole framework, your whole framework of mounting system, everything will be not doing that. So there will be less wastage of solar panels, and for the farmers that will be, they will be using less, they will be cost effective for them, and they'll get more energy.